technology, because the investments may not naturally create the outcome that you want. But let me give you a simple example of some of the positive outcome that can come off mega projects. So let's take the case of a specific project that I was involved in, where this was the development of a light aircraft. It's a light aircraft that is mainly used for coastal surveillance and for like a UAV type of technology, but more for defense work. And the engineers and the aircraft engineers, the aerospace engineers who were involved in this project were doing it from the scratch. They were designing the aircraft. They were involved in coming up with a prototype, but also in the context of manufacturing and eventually, exporting the production of this aircraft. The issue with the whole project was the cost of the overall production from the womb to tomb, because the economies of scale was not there. There was a very high capital investment for the specific country in developing that specific aircraft, and eventually the orders were small. They couldn't recuperate the investment that was put into the aircraft, and eventually the investment and the was not successful. The company defaulted and they went into bankruptcy, and the project failed. But what was the positive outcome from this project? So the investment for the project came from the government of the country, and so the positive outcome from the project was the 10 engineers, the aerospace engineers that were involved in the project, learned from the scratch how to design and build the aircraft, and also learn the business and the economics of the whole operations. They then went away and created newer startups, and they started transferring the tech know-how and their experiences into others in around the country's ecosystem. And some of them became CEOs of other companies and moved on to develop businesses around creating international supply chain, where the country's businesses and governments and industry partnerships work in becoming part of the global supply chain. So there was a creation of a pool of experts in the field. That was the success story of that project. So most often in economic thinking, we go through a linear process of saying, oh, if we invested this much of money, we must get this output, and this is the innovation. But not all projects have got such a linear input output. So there will be other derivatives that would be derived from this specific project. So that is what I was trying to relate around uncertainties, but also around the defense technology and innovation takes a long time. Some of them will take 30 years for return on investment. So it is very difficult to say within 3 years you can see the rewards or the outcome. And the mindset around this is that it's about public good. It's about the nature is that it is benefiting the wider public. Because it's about safety, it's about security. So a country that is safe and security would attract more investment, more business, more foreign direct investments, and so on. So that would be the indirect benefit that a country would obtain, because investors come in when they know that country A or country B is safe in that context. And again, in the context of economics of defense, we also have to consider the funding mechanisms. So how is defense innovation funded? Is it coming through government contracts? So one of the areas where I have a lot of experience is around something called technology offsets or industrial collaboration. So I've got a book that I have written on this in technology offsets in international defense procurement. And it's mainly about how international government contracts can be used to leverage for technology and innovation, and in developing a country's technological ecosystem. There are cost and benefits to it, because end of the day, the cost of developing the technology is being borne by the country that is procuring the defense item. And so how effectively and efficiently is this contract, government contract or international procurement contracts are being used for the right programs and projects. So I do a lot of government advisory work on this, advise international governments and work with them in ensuring that they are getting the right programs and projects that is delivering value. The next one is around private sector partnership. So sometimes specific, technology and innovation will have a very strong private partnership. That means the private sector is interested in the investment. An interesting example I can give you is around the University of Warwick itself. Haura probably would have seen the National Automotive Innovation Centre, which is housed inside the University of Warwick. This is I think a couple of £1 million project. The whole complex is around developing innovation for the automotive sector, around new and emerging technologies, around autonomous skills, around materials, around digitization, around electrification, the development of batteries, and so on and so forth. But this is not a government-funded project; it's a public-private partnership. So some of the money for the project comes from the British government, from their Department of Business and Trade, and some of the money is coming from the industries, mainly anchored by Jaguar. Many of you will know JLR, Jaguar, and some of its SMEs. And the university is coming in as a partner in this context. This is where we see the triple helix working. The university is providing the land, the infrastructure, and also some of the skills and know-how of the professors and the people in this partnership. So not all of it comes in the form of cash. Some can be in kind, and so on and so forth. So that's another model of public sector partnership. And also then in the context of defense, we also see international collaboration, where 2 or 3 countries, I gave you this example, coming together to create that partnership. And another interesting example that I can give you is the Global Combat Aircraft. I don't know how many of you have read about this. It's GCA, Global Combat Aircraft. And this is a joint project between the United Kingdom and Japan in creating the new 6th generation fighter aircraft. Britain, Italy, as well as Japan, in coming up with the state-of-the-art aircraft. There is some conversation around other countries becoming partners to this Global Combat Aircraft project, like, for example, the Kingdom, but nothing has been confirmed. So there will be, this project will be one of the leading projects for Asia that will have a lot of spillover effect for countries in the region, especially in Southeast Asia, where there will be a lot of supply chain requirement and a lot of requirements for small and medium industries, but also for the local prime companies that will have that opportunity. So those international collaborations, again, another way of funding projects. Currently I am working with one of my PhD students from Turkey. We are jointly looking at the effectiveness of international collaboration for industrial in the industrial context for the NORDEFCO countries. This is Nordic countries, Norway, Finland, Denmark, and Sweden, around their projects and how effective is this collaboration, because the European countries are also having a lot of challenges around collaboration, industrial collaboration, and so on. So that's one of the funding mechanisms as well. Next slide. I've put together some key theories. I'm going to go a little bit fast. Martha, I've got about half an hour more.
Yes, correct, Doctor.
Okay. All right. So I'm going to now focus a bit on the technology theories. I think it is very important to understand, as most of you here are students of economics, and also there's some of you are professors and leading experts in the field. I thought it would be good to just put together a few key theories that explains technology and innovation in this space. And some of these key theories are also theories that I look at very closely in the context of sometimes writing my own papers and trying to relate them to the why, answering the why is this important. So one of the theories that I've personally used a lot in my writings and in my papers is around, and I'm sure a lot of you will be familiar with this theory, around the endogenous growth theory by Paul Romer and also Robert Lucas, and how they are focusing on the economic growth, which is not just coming from external sources and externally, but that these technologies has to be grown. The internal is driven by internal factors, and the role of technology, innovation, human capital, and knowledge, which is central to sustaining economic growth. And this is why I use the endogenous growth theory to also emphasize on the importance of collaboration in technology partnership. So it's very vital that organizations and countries develop their own economic, technology and innovation, and develop that capability, not just technological capability around equipment and so on, but also the human capital development. So having said that, my latest paper that I've written is on how to develop human capability for the defense industry sector, and I'll be presenting this paper in the UAE in October, but also hoping to publish. So if the paper gets accepted, it will be one of the first of its kind in for the defense industry sector, that, and hopefully I'll be able to share that with all of you. The next one is, everyone knows this, so I don't have to even discuss this in detail. Schumpeter and his disruptive, creative destruction, and how creativity comes out of destruction, and how it drives entrepreneurship and economic dynamism. That is why a lot of examples, especially from MIT, Massachusetts Institute of Technology, and so on, around entrepreneurship, would use Schumpeter as the leading guru in talking about how a lot of new technologies have come from this creative destruction, the messiness that it creates. The technology push and demand pull theory is another one where we see some innovation is driven by technological push. It's coming from scientific research, from professors and academics and research organizations. But there's also another type of innovation which is coming from the market, from the people and what they want to see. And that's the demand pull that is creating and driving this innovation. And there are various examples around some of this technology push and demand pull theory. The path dependency theory is one where we are looking at history, the technological development based on historical path, and learning from the past. What are the lessons learned from the past, and using that past. So there are a lot of economic historians who like to take this path to looking at the development, path dependency theory, to then predicting the future direction and the success of the technology. And this is, again, a very, very interesting dimension to policymakers in learning from the past to make policies for the future. Next slide. Again, I have used Wesley and Daniel Leventiel, Cohen and Leventiel, in a lot of my papers around absorptive capacity. And in my papers on technology offsets, and even in my book, I've talked about the importance of absorptive capacity, that companies and firms must understand and believe that the capacity, the absorptive capacity, must be present if there is a technology transfer that is happening between partners, the ability to absorb, recognize, assimilate, and apply that knowledge, and having that internal capability to be able to absorb that technology is very important. So for that, you need to have the right people with the right skills and be able to invest in these people and train them and provide them with the knowledge and the education to be able to recognize and absorb that technology, because the machines cannot operate without the people. And this is where we are talking about the man-machine interface. And this is very vital when we say that, oh, everything is going to be taken over by artificial intelligence and we human beings are not going to have any work. That's not true, because you need the people to be able to operate the machines. And AI cannot do all of the thinking for us, especially in the context of ethics and what is right and wrong. The AIs often may not make the right decision for human beings and for the people and for their well-being. So the absorptive capacity theory is extremely important in this context. A lot of you would know the network theory. I won't go too detailed into it, but it's all about social ecosystem and the network that is there. It is about the stakeholders and how they interact with each other, and the connection of the individuals, the firms, and the institutions in diffusing and adopting this technology. And the stakeholders are very important in this network theory. And a lot of softwares and quantitative analysis operate in the context of network theory. And resource-based view, some of my students, I've got 2 PhD students who are now with me understanding and doing their work in innovation and entrepreneurship around innovation ecosystem. And their work is purely in commercial, nothing to do with defense. One is looking at the agricultural sector and the rural development, and how entrepreneurship can develop from, in the rural sector. And the other person is looking at the financial sector. And both of them are using the RBV model, where they're looking at the internal source and capability of a firm as a source of competitive advantage and innovation. So when the firm has got this unique, valuable and competitive advantage, they are in a better position to be able to innovate and sustain for the longer term success. So that is the resource based view, and the importance of capability in-house to develop that competitive advantage. Next slide. So we've looked at a lot of theoretical examples. So these theories are very important in the context of thinking about defense economics and policy making in the defense sector. There are a couple of case studies that I have put together for you. One is the one on success stories of how successful defense technology and innovation has created development and has brought about impact on military capability and defense economics. Not all defense projects are failure. There are a lot of successful projects as well. But I've also put together one project for you on a case study of a project that has failed, and what are the challenges around the project, and what is the lessons learned around the technology, and why they were not able to meet the expectations of the investors, and in this case the government, due to cost overrun, technical failure, and the lessons learned. So I mean, as most of you here would know, I am a practitioner academic, so a lot of my work also comes from practice. So I have done a lot of negotiations around success stories and also failures in this context, working with industries, looking at how some of these technologies and industrial development has been very successful, creating impact, but some which have failed in this context, and the lessons that is taken away from this. Next slide. So I'm giving you one example of a case study of, we talked about computing, and this I think is a very good example of a success story, and how Bletchley Park in the 1940s, through its secret lab in the UK, managed to create its first programmable electronic computer, Colossus, and this was able to break the Germain encryption codes. So this is the most important and valuable innovation that we can ever think of in the history of mankind and in the for technological revolution. And then in the 1960s, the US Defense Agency called DARPA funded this research, and that led to the packet switching networks, and later that becomes the internet. So you can see how the British are very good at invention. Hello, Fiona. I think the line went off for a
Yeah,
while.
yes.
Am I
Yes,
back
yes.
again?
Yes, you are
Okay.
here,
You are
doctor.
back.
Yeah.
Okay, thank you. Because suddenly it got disconnected. Okay, thank you. So this is a very good example of invention. I think it's very important to understand that invention alone is not enough. As we all know, the British are the world leading inventors, but the Americans are the world leading innovators. So the best is to be able to have the art of invention and taking that on to innovation. How do you move invention into innovation? And this again is something that is very challenging. And many of you will know about the Valley of Death, where a lot of the inventions actually sit within the Valley of Death. And how do you then move this into a different space by working with the industries or private sector? And this is very difficult because this is something where I have personally witnessed, because I sit within a university, whether it's, when I was in Malaysia, I was also, with the Defense University and a few other university in Malaya and so on, and now in the UK. One of the most important aspects of making it work is that building the trust between the academics and the private sector. If you cannot build that trust, then the innovation and invention cannot work together. And this is where the United States, for example, has made it work. They're very good in terms of creating that public-private partnership environment and building that trust between the private sector and the public sector. So how do you do that? Because as we all know, when academics invent, we don't know where the technology will land. What is the purpose of that technology and what it is going to be used for? And so this is a very challenging question for academics, because end of the day, the academic world is all about novelty. We want to create novelty and good for use, which is for good purpose. But we cannot control the usage of this technology and innovation when it is taken into the private sector. So how do we create that partnership where we build trust to ensure that the private sector and the public sector, especially the university and the government, are thinking along the same line? But the context of sustainability and the sustainable development goal that has been created by along the United Nations pledge now is one that is really leading this thinking around. All parties need to think about the sustainability of the technology, and the policy that is being created is also along this line. All right, so next move on to the next slide, which is the case study. So I put a link for you here on, and please go to this link to look at the journal. This is a UK Defence Journal, which talks about the Ajax tank. So again, I had the privilege of visiting the site in Wales, in Cardiff. It's a huge plot of land that was barren. There wasn't much going on in this site. So the UK government had this idea of creating a defense industrial cluster. So when you create a cluster, that means that if you go to a brown field and you create a cluster, that means you want to create an ecosystem where then there will be jobs that's being created, shops, housing projects, and you want to make sure that that whole area is being developed. So sometimes governments take this decision that they will go to a brownfield site and start a new project with the intention that this would create many more industries, and it will grow the ecosystem in that part of the world. But the challenge around this is if you are artificially trying to create a cluster, it is much harder, much more challenging because it is not organic. The clusters and the industries are not there. So you're trying to force it into that place. You're trying to make people move in there. So the policy around making it successful is much harder. That governments has to understand. And often, again and again, these mistakes are made because short-term policy decisions that is there to create. Maybe it is tied to constitutions that is eager to develop specific sectors for political reasons. So the AJAC tank is one that was developed in Cardiff. This project is by General Dynamics. And when I went to visit, this was a brownfield. This was 12 years ago. And the UK MOD commissioned a new lightweight series of armored track vehicles for the UK Army. Unfortunately, the project halted because of serious economic problems, not enough funding, but also lack of people that wanted to go and work there. The specification around the whole equipment was over-specified. There was a lot of technical issues when the tank was ready. So you may want to read this paper. I'm not going to go into the details of it, but the project is still active. But many Britishers in the country feel that this project is ever to succeed. It has taken longer, there's cost overrun, budget overrun, and they are not able to deliver to the technical specifications of the project. From the beginning, from this word go, the project has had many, many issues. So that's one of the examples of a case study of a project that had failed. There are many other examples that you can read in your leisure time. So next slide. And considering I have a couple more slides. So the current trend and what are the future direction in the context of technology in the defense economic space. So there are many emerging technologies that has come about, and these are going to have a huge impact in the defense sector. We talked a lot about the AI, we talked about UAV, and there are hypersonic weapons and also space capabilities. And if you see, many of these capabilities, again, are being driven by the commercial and the private sector. So the challenge for the defense sector is around the open innovation. To what extent can they tap into the commercial sector? How open can they be towards integrating and working alongside the commercially driven technology and tapping into the commercial sector to leverage this for the defense sector? So the open innovation concept becomes extremely important. The trust aspect becomes important. The relationship that needs to be built with the commercial sector becomes important, because it's almost a synergy of integration between the defense and civil sector. And this is something that is very important in the space of policy and economics around managing and considering the budget implications in the planning and development of the overall technology. Also, the role of defense innovation, a key question is, do innovation hubs and academic research play a role in fostering a new technology? Because the military systems disturbs the balance of power, for example, and it destabilizes the status quo, and there are consequences around this for the ecosystem. So how does this balance of power play out in the longer term? This is a very important question for policymakers in the wider context. Next slide. So I think we are coming to the end of the session. In terms of policy and ethical consideration, it is very important when we talk about defense economics to think about the policy and ethical consideration of new military technology. Most countries do not want to enter into an arms race. This is not good for a nation and for the economy. So how do we ensure that the policies that are being developed has got huge ethical consideration in terms of the money that is being invested into this technology? Is it better invested into other technologies that has got wider societal positive implications? And then also around ensuring that nations are adhering to arms control agreements. What are these arms control agreements? How are they being adhered to? Especially around managing the whole of the technology, the export control licenses, where this technology is being diffused into, how it's being shared, how the technology is being firewalled, and so on. There are a lot of questions around the arms control. And as I mentioned, the implications around the autonomous weapon systems and the major issues around the balance of power and the destabilization that it may create. So the ethical consideration on the whole around issues like artificial intelligence and cyber technology, as well as autonomous weapons, is very, very, very crucial. And again, I talked about the man-machine interface and how these issues will have to be at the forefront of technological thinking. Next slide. So in summary, what I want to say is that technological development is deep, and industrial innovation is deeply woven into defense history. So it is important that every nation understands its defense history, understands its geopolitical considerations, understands the foreign and defense policy of the nation, and the issues around the whole environment and ecosystem, while planning the technology development and historical industrial innovation. And a good example of this was the dynamite mining invention that accelerated modern warfare. And the question to ask is that, does defense spending always lead to dual-use technology spin-off? The DARPA was an example, an interesting example of that. But does this happen in every case? There may be examples of where defense technology or defense spending does not lead to technological spin-off. And there could be other areas where actually defense spending could be focused on spin-ons, where the spin-ons, the investment goes into the commercial sector. Or can we argue defense spend is an inherent negative economic drag on society? So this is a very, very important question to think about. So in simple terms, what I want to say is there is no simple answer to world defense spending that results in positive economic impact. So we cannot say that all of the defense spending is going to create a positive impact. Some projects may result in positive impact, as we have seen, and examples are there where it does create huge impacts. And we talked about the internet, but also there are other examples, and I gave you the example of Ajax. For Indonesia specifically, what kind of policy do you want to create, especially when you're thinking about defense R&D, research and development? What are your considerations around the whole spectrum of thinking about going wholly indigenous and creating a fully whole indigenous capability for self-reliance? Or are you going to go for procurement of the shelf for most of it and think about partnership and international collaboration for others? So this is a very important and vital question that Indonesia, for example, need to think about. And then intelligently pick your partners if you are thinking about creating that technical innovation capability. Who are your partners, and how do you, want to create that partnership? I will leave you with this interesting example based on the recent Ukraine-Russia war. There is a lot of collaborative effort that is taking place within the former Soviet bloc especially within Central and Eastern Europe. So one of the interesting collaborative activity is between the Baltic states, mainly Latvia, Estonia, and Lithuania, the smaller, beautiful countries, and Sweden with Ukraine, in collaborating around novel UAV technologies, which is of very much a dual-use technology. So the collaborative technological environment will be extremely useful in building a very strong capability for air defense. They are drones, they are very highly capable, easy to use, and this would be of vastly useful to Ukraine. But then you will have multiple countries coming in to support with this initiative. And I've also written an interesting paper around ASEAN Defense Industry Working Group and ASEAN collaboration, and also was part of that ecosystem when I was in Southeast Asia, trying to strongly encourage the collaboration within Southeast Asia for specific dual-use technology to address perceived issues around non-traditional and traditional security in the region, and how to build joint or encouraging around building shared platforms. So with that, I think I'm spot on in terms of time. Finished just on time, and thank you very much. And I'm now open to questions. Thank you.
Thank you very much, Dr. Kogila. So I have learned a lot. I haven't taken so much notes myself. I'm keen to ask and discuss with you, but I think I'll give the time for students first. Is there any questions from students or colleagues here? Because even like what Dr. Kogila mentioned, intelligently pick the partners. So I think we have to be intelligent in picking the partners, whatever in life or in defense economics, I think. Oh, okay. Yes, Fiona, do you have any question yourself, please?
Yes. Thank you, Dr. Kogi, for the amazing explanation. I do have a question. While governments are the primary investors, like in R&D for economic defense for the sake of the security for a country, and Dr. Kogi also mentioned that the role of private sectors companies in developing defense technologies, and like how significant is this? Like, do you have any examples of private sector contributions to defense R&D? And let's say US, is it mostly managed by the government or the private sector? Yeah.
Sure. Thank you, Fiona, for this question. It's a very, very important and good question. So we go back to the question of the defense industrial structure. So there are different types of defense industry structure. One which is wholly owned by the government. So they are state-owned defense companies, and the government has a very strong relationship with these companies, and they are part of the government ecosystem. And I think in Indonesia probably there are some companies there are, I'm not sure about PT Pindad whether it's wholly private, but there are a couple like in other countries that are wholly, like if you take the case of countries like Cambodia, Vietnam, even in some of the Eastern European countries, as well as Russia and China. They are all government owned, state runs the companies. Then you have another type of company, which is they are public-private partnership. They are like the government-linked companies or GLCs. So the government has a golden share. That means if the company has a problem, the government will come and say, okay, we are going to save you. So in Malaysia, for example, and I think Singapore as well, and maybe Indonesia, this is a very popular model. So they almost operate like private companies with their shareholders and so on, but they will have government representative sitting on the board, like the Ministry of Finance or Treasury, or other organizations that will be closely monitoring the governance. And if there's a problem, then the government will take over this. They will be nationalized back, because there's a strong interest of the government. Then there's a third type of defense industry, which is wholly private owned. The government doesn't have anything. So in the West, for example, in the United States, some of the European countries. France is very much government owned. A lot of their companies are still nationalized, but Germany, United Kingdom, many of these companies you would have heard, like big companies like BAE Systems, Northrop Grumman, Rolls-Royce, or General Dynamics. They are all private companies, wholly private. Government doesn't put any money into them. Maybe it has a critical, like if there's a major issue, it might interfere, but they are whole. So in this context, the investment and the R&D operates in the different ways based on the government partnership. So for companies like BAE Systems, let's say BAE Systems or MBDA or Rolls-Royce, because they are private companies, they have to create their own R&D departments, funding. They will get some government support. So the research grants that are being announced by the government and by, like in the UK, they have funds like Innovate UK. They have something called DASA, Defence Accelerator Challenge. So the private sector can apply for the grant and they can jointly collaborate with the universities and with, with other research organizations. Like in Indonesia, you have something called BRIN, right? That's a research organization. So in the UK, there are also other research organizations like DSTL and so on. And universities, they will jointly collaborate and create partnership. But the private companies have to do a lot of their R&D on their own. So I give you an example. So my husband works for British Telecom and he works for BT Security, British Security Research Future Practice, which means that a lot of the research he does, he has to look for his own money. He has to apply for the grant. He has to find the money either from the government, apply, or the company itself has to invest in creating that pot of money to do the research, right? So that is the kind of model they have in some of these Western countries. But in other contexts, like if it's wholly government owned, like case of India, again, DPSUs, they are government owned companies, China, Russia, because they are all government owned, government is the one that is pumping in the money continuously into these companies to create the R&D. So you need to think, is this an effective model? Because a lot of so sometimes it's also around the question of check and balance. How much money is being put into this kind of investments into the defense industries? Where is the transparency around the questions of how much is enough into this kind of industries? What is being produced? So that are some of the challenges depending. So a lot of it is also got to do with the political structure and the government industry relationship. Okay. There's no simple answer to it, but I'm giving you the context of how it works. So Indonesia has to create its own model around what is the best for Indonesia. Does it want to create a public-private model around the defense companies like PT Pindad, PT PAL, I think it's now the UE, used to be PT Dirgantara, the air I can't remember the name now. So there are a lot of these defense companies. So are these companies state-owned? Are they public, private, completely private? Or is it better for Indonesia to have a public-private first, where they are private-led and they have to do their own research, but then the government, and also you have to remember, for a defense company to be solely private, they must be able to export. They must be able to generate their own income. If they are not able to do that, if they are still dependent on the government as their single market, then how are they going to have money to do R&D? They are still going to depend on the government. A lot of the examples I'm giving you here are the big OEMs. They are exporters of defense equipment. They are able to get so much money that they can reinvest this into the R&D, right? And so those are the considerations. So maybe start small and then build it up. But the responsibility of the private sector is very important in this context. Yeah. Okay.
I think it's answering the questions, right, Fiona? I can see Fiona is so satisfied with the things. So thank you, Dr. Kagila. So I see Dea, would you be able to speak by yourself? Please raise the raise the questions. Thank you.
Thank you, Dr. Kogi, for the opportunity. I want to ask, in what ways can advancement in defense technology contribute to economic growth? As we know, when considering the allocation of spending for a country, there are many industries to focus on for developing their own country. Thank you, Doctor.
Okay, thank you. So how can the defense industry or defense contribute to economic growth? Which one was it? Is it defense industry or defense? Dia? Sorry, I didn't get did you ask whether it was the defense industry or defense?
Defense industry, Doctor.
Defense industry. Okay, thank you. So I assume you didn't attend my last lecture, the third lecture. So I did talk a lot about this in my third lecture around how defense industry contributes to economic growth. So I will give you a summary of it here. So when we talk about defense industry, a lot of us have this misconception that the defense industry must provide economic growth. So the primary role of the defense industry is not to produce economic growth or to deliver economic growth. The primary role of the defense industry is actually to support the military, to support the armed forces in providing them with the capability for them to be able to defend the nation, right? So if a country wants to measure the contribution and the success of the defense industry, the benchmark, the key benchmark cannot be economic growth. The key benchmark must be, is the defense industry self-sufficiently capable and effective and has got the right level of industrial capability to support the armed forces of the country in terms of if they are going for a specific mission, whether it's peacekeeping, whether it's disaster management, whether it's war. Can they do that or not? That is the primary measurement. The secondary measurement is then about economic growth. So is the defense industry contributing to job creation? What kind of job is being created? Is the defense industry able to then, create exports, able to export some of the products? Is the defense industry able to, generate more? If there are larger companies, are they able to generate more smaller SMEs that are able to then, produce second tier, third tier goods and products and services? So those and those are the economic measurements that you can then look at as a secondary tier, right? So to answer your question, you need to categorize what is the primary role of the defense industry, what is the secondary role of the defense industry, and third role of defense industry. If you only focus on saying that defense industry must produce economic growth, then a lot of countries will be disappointed because the defense industry does not always produce economic growth. Because as we talked about in the earlier sessions, the return on investment from the defense industry takes a very long time. When a country starts building its defense industry, the investment is very high. The output and outcome is also very long. It takes a long time. Okay, so these are the challenges that the defense industry sector has. So a country needs to consider these challenges and not say, oh, if we invest XY amount of money into defense industry, we must be able to export, we must be able to generate lots of jobs, we must be able to create this. And the economic, if you're only measuring it in the economic terms, then it will seem like the defense industry is always a failure. Okay.
Okay, right. Thank you, Doctor, for providing the summary of the previous lectures. So I think I can take one more questions. One more question, please? Any students would like to ask questions, or I will take the chance? Okay, so I think if I may ask the questions, Dr. Kagile, so you mentioned about a country has to put or has to take which priority regarding the defense industries. And when we check in Indonesian case that we do have the priority of defense industry, because in Indonesian national long-term planning for 2023 up to 2045, one of the priority industries is defense industry. So we do have the priority. But then you mentioned as well about the indicators of technology such as patent and everything. In that case, Indonesia has still in a really low rank compared to other countries. So I know it is not a simple answers, but then is it possible for us to get like brief insights? What first thing first that we have to do? Because we have the priority, but then the resource is not that good, I think, if I may say. So could you please give us
So
one?
from a policy, economic policy.
Yeah. Yes,
Sure.
from economic
Thank you
policy.
so
Yes,
much.
thank
This
you.
is a very important question. Yeah. So from a economic policy perspective, I would say that yes, you've got your defense 2023 to 2045 policy, and in the policy, I am not sure whether you have mentioned that there should be there is a need for defense industry.
Yes.
And whether there is a requirement for them to build a defense industrial strategy. Because the defense industrial strategy is one that should then create the prioritization for you in terms of identifying the key areas that you need to build on. And this defense industrial strategy should not be developed in isolation, but it should read along the lines of looking at your national security policy. What is Indonesia's key national security considerations? And then looking at how is it aligned to your defense policy and foreign policy? Because because you cannot work or you cannot align your defense policy without considering Indonesia's foreign policy.
Yes,
okay.
yes.
So these are very important. So the defense industrial strategy would then give you, that means then you have to work with the key stakeholders, and the key stakeholders in this context are the end users, which is the military, and what is the capability that they require, identifying that capability, and then working alongside with deciding your procurement and equipment needs. And this would then make you understand which are the
Recording in progress.
which then would allow you to plan better. So that means having that defense industrial strategy is extremely important.
Yes. Okay. Right. Okay. Thank you, Dr. Kogila. So, I wish I had more time with you. So then please come to Surabaya and we can discuss more. So, yeah. So I believe today's lecture will enlighten us about how technology is important, but then we have to think that how we implement the technology as well as how to prepare all the things